All right, in the last lesson, we learned to solve systems by graphing and seeing where the two graphs intersect. We're going to move on to a new idea that is solving systems using substitution. It's an algebraic method, and the reason why it's a good method to use is we can get exact answers. If your lines do not cross at an exact point on the grid point and there's some fractions or decimals in there, we saw some of those examples in the last lesson, then you're kind of guessing at what the answers are, which for a lot of real-life applications would not be the way to go. You don't want something necessarily close to the answer. You're going to want the exact answer. And so using some algebra, we can actually make this happen. So substitution is exactly what it sounds like. We're going to replace something with something else. So on the first two equations, they're in slope-intercept form, y equals mx plus b. So I'm going to show you what we're going to do. I'm going to highlight this. You don't have to, but it just kind of helps you see what I'm doing. I'm going to replace this y that I've highlighted with the 4x minus 11 up here. It's y equals this and it's y equals that. So we're going to take the y's out and put this down here. So instead of y, I'm going to have 4x minus 11, and then the rest of the equation down here equals 5x minus 15. Sometimes people think of this as just making the x part of the equation equal the other x part of the equation. And the beauty in doing this is we've got the y's out of the equations, and now we just have an equation that we can solve like we've been doing since 8th grade. We can get everything to one side and just solve it. There are x's on both sides, which sometimes throws people off. I've got 4x here and 5x there. They're both positives, so to get them all on one side, we need to subtract either one or the other. I prefer to subtract the 4x and keep everything positive, but if you want to subtract 5x over here, get negative x and work with that, you should get the same answer if you do everything correctly. It's not a problem, but you want to get all the x's on one side. So now I have negative 11, 5x minus 4x is just 1x, or I can just write an x, and then minus 15. Okay, so we want to get x by itself. We're getting rid of minus 15. So now we're adding 15 to both sides, and we'll get 4 equals x. Now, don't get super excited. We're not done yet. Remember, we're looking for where these two lines cross. So my final solution is going to have an x and a y. It's a coordinate pair. It's a point on the graph. So we just found the 4 is the x part. We still need to figure out the y part. So what we do is we know that x is 4. We choose one of these equations. It doesn't matter. And we're going to put the 4 in where the x is. So y equals 4 times, it was x, we're going to put in 4. So 4 times 4 minus 11. So that would be 16 minus 11, which is 5. And that gives you the y coordinate. So your final answer is still a coordinate pair, an x and a y. It needs to have parentheses. It needs to have a comma. Otherwise, it's not technically a coordinate pair. So make sure that you have all of that together. All right, we're going to do another one where they're both in slope-intercept form. So let's come over here. So what I'm going to do is I'm going to take this part of the equation and I'm going to substitute it for the y down here. So this y is going completely away, and I'm replacing it with x minus 1. And I can do that because that's equal to y in this equation. We can replace things that are equal. So I'm going to put x minus 1 equals negative 3x plus 11. So I need to now get all of my x's on one side. I have a positive x here that I could subtract, or I have a negative 3x over here that I could add. Whenever you can choose adding over subtracting, I feel like we make fewer math errors, so that's what I'm going to do. And that gets rid of the negative 3x over here and just leaves an 11. On this side, I have x plus 3x, so that'll make 4x minus 1, and then it equals 11. And we can just keep solving. So we add 1 to both sides. We'll get 4x equals 12 divide by 4, we get x equals 3. So remember, with my solution, we're going to get an x and a y. So this is basically the first part of that. So we're going to put 3 into one of these two equations for x. Now if I was going to choose, I would say that x minus 1 is a little easier to do than this other one. So I'm going to take this and just make it 3 minus 1, which is 2. And then that one's done. We've got the x and the y. So when we're solving a system of equations, you have to have an x and a y coordinate. They're the points where the lines cross. All right, so now we're going to switch gears and look at a couple of problems where one of them is in slope-intercept form and the other one is not. So I'm going to come down to number 3. So y equals negative 4x plus 22. That's in slope-intercept form, and this one is not. We can still use substitution, but it's going to look a little bit different. All of this that it says is equal to y is going to get replaced for the y that happens to be in the middle of the equation. So it's in the middle instead of on the end. Okay? And let me show you what that's going to look like. So the second equation we're going to copy down as is, except we're replacing y with all of that stuff. So negative 8x, and then plus the 5. We're still keeping the 5, but where this y is, we're going to take the y out, and we're going to put in both of these terms. Now since there's two terms, we're going to use parentheses to show that we're inserting a group there. So that is where the y was, is what's in the parentheses. And then we go ahead and write equals negative 2. So let me repeat what we just did. So all of this is equal to y, which means in the other equation I can replace, the word is substitute, y with all of this. And I did that in parentheses. So the y is not in here. We don't want y's in the equation anymore, just x's. And so we can put that in there. So we created this situation where we have parentheses, and now we're going to get rid of them by distribution. So I'm going to leave this negative 8x kind of hanging out here for a second. I'm going to distribute 5 to both of these terms. So 5 times negative 4x is negative 20x. Let me get rid of that plus and just write minus 20x. It's a little bit simpler. And then I have 5 times 22, which would be 110. So I'll write plus 110 there, and it still equals negative 2. The only thing we've changed is we distributed this 5 out. And that's why I use parentheses, because 5 has to be taken times y, and all of this is what we're putting in for y. So it's all got to get multiplied by 5. Now, instead of having x's on both sides of the equation, I have two terms with x in it on the left-hand side. So if you remember from when we did our equations unit, we combine like terms. I've got negative 8 and negative 20, which makes negative 28x, and then plus 110 equals negative 2. And we go ahead and solve that. So minus 110. We get negative 112. Over here we get negative 28x when this gets canceled out. And if you go ahead and divide by negative 28 to get the x isolated, you will see that you get 4. And then you would go, oh, I'm done. Oh, wait, no, I'm not. So that is the first coordinate to my answer, and then I've got to go back and find y. So 4 can go into either of these equations. What you want to do if one of them already says y equals, you want to use that. So that's what we're going to do. So y equals negative 4 times x, which we just found out was positive 4, plus 22, which is negative 16 plus 22. And so I think that's going to give us 6, if I can do the math right. So that'll give us 6, and that's the y coordinate. So we'll take that, put that down here in our parentheses, and this is my final answer. Okay, let me zoom out just so you can see that again. So we solve for x, and then you take x and substitute that in for x in this equation. And I chose the y equals equation because I could just do some order of operations or put it in my calculator. It's just straight arithmetic. If I put it in for x down here, I would then have to solve for y, which is a little bit more complicated. So it's better if you have a choice to put it into an equation that's in that slope-intercept form. It just makes the math and what you have to do a little bit more straightforward. Okay, let's go on to number 4. So I need to identify which one's in slope-intercept form, and it happens to be the second one. So this is equal to y. So that's going to go in for y up here. So look, so you can see my arrow. So this is equal to y. So that means I can substitute it for y in the other equation because we're looking for where these meet. We're looking for the x and the y that makes both equations true. So what we will do with this now is rewrite the first equation with this in there for y. So I keep the negative 3x, I keep the minus 8, but when I get to y I go, oh wait, that's where I'm going to substitute 3x minus 8. So I make some parentheses just to include the whole group. There's 2 terms there, so that's important. So I replace the y, and then I go ahead and finish the equation, equals 10. So the only part of the equation that's coming out is the y, and all of this is going in where the y came out. And then we can simplify this a little bit and distribute. So the negative 3x, like here, just stays negative 3x for a moment. We'll distribute the negative 8 over here. So negative 8 times 3x is negative 24x. Negative 8 times negative 8 is plus 64, and that equals 10. So negative 3, negative 24 are on the same side of the equation, which means we just put them together. I don't have to do opposite operations and add them. I'm just putting those together, which makes negative 27x plus 64 equals 10. Next step is to subtract 64 from both sides, so we get negative 27x equals negative 54. And now we're down to just a one-step equation. We'll divide by negative 27, and we get x equals 2. So that's half my answer. I'll put that in for the x coordinate. And then to find y, we want to put 2 into the equation that's going to be easier to deal with. The one that's in slope-intercept form is easier. So where I have that x, I'm going to put in 2. So it'll be 3 times 2 minus 8. And you could just write a time sign between the 3 and the 2. I like using parentheses just so I don't get confused and think it's 32. So 3 times 2 is 6, minus 8 is negative 2. We put negative 2 down there, and that is my solution. Okay, so we're kind of doing these in pairs. We did 2 that were both in slope-intercept form, 2 that had 1 in slope-intercept form, and now we're going to switch to something that looks a lot different, but it's actually going to work basically the same way. Instead of having a y equals equation with the slope-intercept form, we're going to see an x equals equation. So this is what we get here, 2y plus 4. And instead of substituting for y, since it's equal to the x, it'll go in where the x is. So it's still the same idea. We're just going to work it a little bit backwards from what the others looked like. So this top equation is where I'm putting the 2y plus 4. So I'm going to keep the 8, but instead of writing x, I'm going to put in 2y plus 4 as a group with parentheses. And then I need to look back and see what else is in the equation. So I have minus y equals negative 13. All right, so we get rid of the parentheses by distributing. So let's do that. So we'd have 16y plus 32 minus y equals negative 13. So if I look, I now have 16y and minus y on the same side of the equal sign, so I'm just going to do that. 16y minus y is 15y. And I have plus 32 equals negative 13. All right, next we subtract 32 from both sides to get the term with the y in it by itself. So we get negative 45 over here, 15y over here. divide both sides by 15, and we get y is -3. Now since this is switched up a little bit, and they're giving us, we're getting the y coordinate first, you need to remember when we put it into the parentheses for the ordered pair that y is the second number. And we're going to go back and solve for x, which would be the first number, the first coordinate. So it's kind of like what we did with the slope-intercept form, except we're going to use the x equals equation instead of the y equals equation. We're going to put -3 in for this y. So x equals 2 times -3 plus 4, which would be -6 plus 4, which is -2. So now that goes down here as my x coordinate. Okay? One more of these, and then I'm going to talk about how you can check your answers. So let's go over to number 6. So on number 6, my top equation is x equals 5y minus 15. So what I'm going to do is I'm going to take all of that, since it equals x, and I'm going to put it into this equation down here where the x is. So I'm going to keep the -6, but I'm replacing x with 5y minus 15. And then minus 3y equals -9. It's just the rest of the equation that was there. We're just replacing that one piece, that one letter, that one variable with this expression. All right, so we solve. So we'll distribute first. -6 times 5 is -30y. -6 times 15 times -15 is +90. Make sure you watch your signs. And then we've got some like terms on the same side of the equation. So -30 and -3 make -33y, and then I still have the +90 equals -9. We just go ahead and solve this like we've been doing for what seems like forever. So subtract 90 from both sides. That gives you -99. On this side we'll have -33y. So we'll divide by -33. We get y equals 11. So remember on our point it goes x, y, so that is the second coordinate, is 11. And so this is going to go back up into that first equation that says x equals, because we want to know what x equals to get the x coordinate. So we'll have x equals 5 times 11 minus 15. So that'd be 55 minus 15, which is 40. So that's going to go down here in the x coordinates place. So we talked about in the previous lesson that you can check these by putting these numbers in for x and y in both equations, and that is still true. If I put in 40 right here, 40 in for x and 11 in for y, I should get the same number on both sides. When I put 11 here, 55 minus 15, I get 40. It's equal to the 40 that would be over here. If I put 40 here and 11 here, I should get -9. This solution has to work in both equations. So you can substitute this in for x and y, make sure that the equations work, and always know that your answer is correct. And if you're confused about what I'm talking about, look at the last set of notes. And we talked about how to check solutions to systems of equations. That should help you out.